Alright, let's do one more thing before we get into doing examples of when we can use these for inverse functions. So first notice that if we have the reference angle of an angle, then the absolute value of the trig function is going to be the same. Okay, so what I mean is, say for example, that we take sine of, let's say, let's do 225 degrees. So what does that equal? Okay, well that equals negative root 2 over 2. Okay, and then the absolute value of that is going to give us positive root 2 over 2. Alright, now because 225 degrees is in the third quadrant, that I know that theta r is going to be 225 minus 180. That's going to give me 45 degrees. Then, by what this says up here, if I take sine of theta r, which is going to be sine of 45 degrees, I should get back root 2 over 2, and if we plug this in, indeed we do. This is a more powerful formula than you would think, because I can take any angle that shares a reference angle, and they're going to have the same absolute value. So for example, let's say I want to find an angle in quadrant 3, or quadrant 2 rather, that has a reference angle of 45 degrees. Okay? So 45 degrees equals, and then my formula for quadrant 2 is going to be 180 degrees minus theta. Okay? If I solve for theta, then I'll get that theta equals 135 degrees. Alright, now if I plug that in here, then I'm going to get sine 135 degrees, the absolute value of that, and that's going to give me root 2 over 2. Right, this also holds true for cosine, cosecant, secant, cotangent, and tangent. Okay, so a little visual representation of what's going on here. Is that I'm always going to have 4 values on the unit circle that have the same absolute value for y, and that have the same absolute value for x, save for 1, 0 and these vertexes here. Okay, so notice at 30 degrees, I have sine equals 1/2. And also at 150 degrees, I have that sine equals 1/2, and that also has a reference angle of 30 degrees. At 210 degrees, I have that the absolute value of sine equals 1/2. So even though sine equals negative 1/2, the absolute value is still 1/2. And notice that that also has a reference angle of 30 degrees. Okay, the same situation holds true here. I have 30 degrees as my reference angle for 330, and the absolute value of sine here is also 1/2. Okay, if you want to go ahead and check on your own, the same holds true for our cosine values here, and they also share the same reference angles. All right, so let's go ahead and do an example. All right, so what are reference angles used for? Well, we just said they're used for inverses. So let's say that we want to find all values for theta between 0 and 360 degrees. Okay, so we take sine inverse of both sides, and we get that theta equals sine inverse of 1/2 equals 30 degrees. Okay? So if we go ahead and draw a picture of that, we know that because sine is our y value, we know that we're going to have 2 spots that have sine equal 1/2. And from the theorem that I just showed you, we know that both of these points are going to have the same reference angle. Well, since this angle is positive and in the first quadrant, it is its own reference angle, so we don't have to do any work. That's really nice. All right, so then we know that our second angle is also going to have a reference angle of 30 degrees. Okay, so what we're going to do is that we're going to take, since it's in quadrant 2, we know that our reference angle equals 180 minus the angle that we want. And since we know our reference angle is 30, we're going to do 30 degrees equals 180 minus theta. When we solve for theta, we're going to get that theta equals 150 degrees. So that's perfect because we know by looking at the unit circle that at 150 degrees, we do indeed get that sine equals 1/2. We could also double check this by plugging sine of 150 degrees into our calculator and also confirming that that would indeed equal 1/2. All right, so let's do another example. Okay, so let's say that we are asked to find sine of theta equals 1/3, and let's say that we're asked to find theta when theta is between 0 and 360 degrees. Again, because sine is our y value, we know that we're going to have 2 points that equal 1/3, right? So we're going to have 1 point in quadrant 1, 1 point in quadrant 2. Since the answer that we get when we plug into our calculator, right? So if we plug in sine inverse of 1/3 into our calculator to get theta, we're going to get 19.47 degrees. Right? If you don't get this answer, go ahead and make sure that you're in degree mode and not radian. Okay. So like I said before, because these 2 points are going to have the same reference angle, and we know that the other side is going to terminate in quadrant 2, we're going to use our quadrant 2 formula. So our quadrant 2 formula, which is that our reference angle equals 180 minus theta. Okay. And our Q is 19.47 degrees equals 180 minus theta. And then we're going to solve for theta, and we are going to get that theta equals 160.53. Right, so this other theta here, theta 2 I labeled it, I should label it here too, sorry about that. It's going to be 160.53 degrees. Alright, so let's plug this into our calculator, and let's make sure that that checks out. Okay. So first let's check that this one makes sense. So let's go ahead and do sine of 19.47, and we get 0.33313, so that's about 1/3. So that's good. Now let's try sine of 160.53, and we also get 0.33313. So both of those work out. So that's great. Okay, so let's try another one. All right, this time we're going to do a negative. Okay, so now we're doing a negative y value, so we're going to be down here on the unit circle. And again, we're going to have 2 points where sine equals negative 0.23. Okay, so what I'm going to do is that I am going to take sine inverse of this to equal theta. Okay, I plug in my calculator, I'm going to get negative 13.29 degrees. So this theta equals negative 13.29 degrees. Alright, now because this angle isn't positive, that means that it's not a reference angle. Okay, so because it is an acute angle, what I can do is that I can just draw the angle going the opposite direction. Okay, so that way my theta r is going to be positive 13.29 degrees. All right, so if the absolute value of an angle is less than 90 degrees, then we can just take the absolute value to be our reference angle. Okay. Now, our other side terminates in quadrant 3. All right, so our other Q, call this Q2, call this Q1, terminates in quadrant 3. So our rule for quadrant 3 is that is that theta R equals theta minus 180. Okay, and since we know our reference angle, that's going to be 13.29 equals theta 2, minus 180. Okay, then when we solve for theta 2, we get that theta 2 equals 193.29 degrees. All right. Now we're not finished because I wanted both of these answers to be positive. So I just need to find the the coterminal angle of this. Okay, so then the coterminal angle for theta 1 is going to be 360 degrees plus my negative 13.29. Okay, let me see what that's going to get me. 13.29. So I get that theta 1 is going to give me 346.71 degrees. And my other answer, theta 2, is going to give me 193.29 degrees. Okay, and that looks about right. If I were to just eyeball this, I would say that that is about 346 and some change degrees. And I would say that that's about 193 because that's a little over 180. Okay, again, let's plug these into our calculator, double check our answers. So let's do sine of, let's do 346.71. Oops, 71. Okay, and that gives me negative 0.22988. If I round that, that's about negative 0.23, so that's good. All right, and now let's do 193.29. Also good, perfect. Great, now let's do a couple examples with cosine. Okay, now remember that cosine is my x value on the unit circle. So that means that cosine of theta is my x value. All right, so I'm going to be looking at when cosine of theta, or when my x value on the unit circle is 1/4. So now I'm going to have two spots going like this, right? Because I'm going to be looking at when x equals 1/4. Okay, so again, when I plug this into my calculator and I solve for theta, I get that theta equals 75.52. Okay, so this angle, we'll call this theta 1, is 75.52 degrees. Okay, and since this is in quadrant 1 and it's positive, then it's already a reference angle for itself, so it's good. So then we know that theta r is 75.52 degrees. Right, now my other angle terminates in quadrant 4, and will also have the same reference angle as the initial one, as the rule says. So, since it terminates in quadrant 4, we have that theta r equals 360 minus 75.52 degrees, or whoops, minus theta, sorry. All right, so that means that 75.52 degrees equals 360 minus theta. All right, then if we go ahead and solve for theta, we are going to get that that equals 284.48 degrees. All right, so my two answers be theta 1, 75.52 degrees, and my theta 2 is 284.48 degrees. All right, let's go ahead and check our answer again. So let's do cosine of 75.52. So we should get about 0.25. Perfect. All Right, now let's check it again for this, 284.48. Wonderful. Those look great. All right, let's just do one more example with cosine. Okay, so again, we want to find theta where theta is between 0 and 360, just like the other ones. And this time, cosine inverse of negative 2/3 equals theta. So we plug this into our calculator. We get that it's 131.81. All right, so that means that this angle, call this theta 1, 0.81 degrees. Now this isn't as nice as the other ones because this isn't a reference angle. It's also not acute, so we can't just take the absolute value. So what we're going to have to do is that we're going to have this find this theta r here. All right, now because we terminate in the second quadrant, so because we terminate in quadrant 2, I know that theta r is going to equal 180 minus my angle, which is 131.81. Right, so if I do that, 180 minus 131.81, then I'm going to get that theta r equals 48.19 degrees. Right, and since theta r is going to be the same for both of these, because that nifty rule that we had, theta r. Okay, then I know that my second angle here is going to terminate in quadrant 3. Right, so then theta 2 is going to terminate in quadrant 3. So if I use my rule for quadrant 3, write that down here. So my rule for quadrant 3 means that theta r equals theta minus 180. Okay, well, since I know that theta r is 48.19 degrees equals theta minus 180. Okay, now I solve for theta. Yeah, theta equals 228.19 degrees, or that's my theta 2. All right, and then my theta 1, just right down here for convenience, it's 131.81 degrees, so these two would be my answers. And again, check these in our calculator. All right, so 2/3 is about 0.666, and since we have negative 2/3, that's great. Okay, now let's try 131.81. Oops, 0.81. Perfect, also the same. Okay, these take a lot of practice. To really get down how to do these, I always suggest drawing a picture. That way you know which quadrant you're terminating in, where your theta r's are coming from, and how to apply them. Okay, so if you ever get stuck, go ahead and draw a picture. Remember that cosine is going to be your x value and sine is going to be your y value. Okay. Now, let's go ahead and move on and look at some examples of how we can use this in the next video.